everybody. Harold here. Today I want to talk to you about handling nulls in Polar's data frames. We're going to talk about counting them, filtering them, how to drop them, all the different ways you can fill them, talk about NaNs, uh, why do we use Polars for missing data. We can use expression-based null handling, works seamlessly with our lazy frames. Again, the predicate and projection push down, and it's faster and more memory efficient than pandas. So I've got a small data frame with some nuns and one nan. I'm in Google Colab. I've imported polars as PL, NumPy as NP, so I can have a nan. And from Rich, I imported print for the pretty printing. Let's just take a look at this data frame here. So I've got ID, sales, region, and growth. First row is fine. Second row has a null and a nan. Third row has a null. Fourth has two nulls. Fifth has a null. So to count null values per column, I'll say result equals df dot select. We're going to use pl dot all for all columns. Dot null count. And then we'll just print that result. And ID 0, two nulls in sales, two nulls in region, one null in growth. Notice it did not count the NaN. It doesn't count those. It's a separate value to polars. If you want to put explicit labels on them, you could say, let's copy this down. Right after null count, you can give them a name, so you could dot name dot suffix. We'll say underscore nulls. So that just gives you sales nulls, region nulls, growth nulls. That's just a cool way to name your null columns in your count nulls data frame. I'm going to count nulls per row. I can say result equals df dot with columns pl dot sum horizontal by row. Then again pl dot all dot is null, and we'll give that an alias. This of nulls per row, and we'll print that result. So nulls per row, 0, 1. Again, it doesn't count the NaN, 1, 1, 2, 1. Filtering nulls by row. If I want to filter out any row that has, or extract any row that has a number, a null in it, I could say result equals df dot filter pl dot any horizontal cell has a null in it, pl dot all dot is null, and print that result. So the top row, 1, didn't have any nulls. It's not there, and the rest of them are. If you want to do the reverse, uh, for time's sake, we'll just copy this paste, change any to all. And is null to is not null. And there we just have the row that has all good values in it. If you want to filter by a specific column, if you want to filter by a specific column, you could say result equals df dot filter pl dot call region dot is null. And we can print that result. Okay. So that just filtered out columns where region is null. Now, dropping nulls, be careful. Filling nulls, be careful. It's a quote. Missing data isn't just an inconvenience, it's a decision point. Every null forces you to choose between distortion and omission. You are changing your data. Make sure you know how that's affecting your final analysis when you do that. That being said, drop any row with nulls, drop them all, result equals df dot drop nulls, and print results. Well, again, why I want you to be careful. What have you got now? One row. What are you going to do with that? Drop only the rows with nulls and sales and growth. Okay, you can get a little more particular about it. Result equals df dot drop no dot drop nulls. You can give it a subset, and that's a list of columns. We'll just drop in sales and growth and print result. And now we've only dropped the nulls in sales and growth and left them in region. The NaNs as result equals TF. They have to be handled separately. Dot drop NaNs and print result. So the NaNs value is gone, but all the nulls are still there. Now, filling the nulls. Oh, again, be careful, but you could fill it with a constant value. Result equals df dot width columns. pl dot call sales. I want to say I want to fill those nulls. Not fill null. I want to fill the sales nulls with zeros. I want to fill the region. Zero is probably not a good idea there. So I will, but I want a value, so I'll say fill null, and we'll just say that the region is unknown. And let's print that result. So all the nulls are zeros. All the regions unknown are NaNs still there. All the nulls and sales are gone. Regions unknown. Didn't do anything to growth. Uh, there are strategies. Fill forward. So results equals give dot with columns. PL dot call. Sales dot fill null. And you say strategy equals, and these are in quotes, forward. Then we'll print result. So 100 went to 0. Now it goes to 100. It filled it forward. 300, 0, 500, 300, 300, filled it forward. Do backwards. So we'll just copy and paste and change our strategy to backward. And now 500, 500 went backward, 300 went backward. Okay, so you could fill forward and backward. You could fill it based on a condition. Oh, like a when then otherwise. So result equals df dot with columns field dot when field dot call sales dot is null. You could dot then field dot call sales. Use mean. And then otherwise, just use the sales. So either the mean or the sales that are already there. And let's give that an alias of sales filled mean. And let's print that result. So we've got our existing data frame and then an additional column, sales filled with the mean. The mean of sales was 300. It filled the two null values with the 300 using the mean based on my when then otherwise statement. You can also use linear interpolation, use regression, a little more complicated. I won't explain the math behind it, but result equals df dot with columns pl dot call sales, just dot interpolate, and we can print that result. So it's interpolated that 200 and 400 will be those values based on the linearity. It's pretty obvious from this example how linear it went. Uh, Before I finish up, a little more on NaNs. You can count the NaNs. I'm not going to do much with them. Or NaNs, NaNs, however you want to say it. Result equals df dot select pl dot call growth. the one we have a NaN in. Dot is NaN. Well, you pretty much got a sum of dot alias NaNs, not nulls, NaNs, and print that result. So I have a one column, one row data frame, U32 NaNs. There's one. Uh, all that being said, the best way to deal with NaNs is to just turn them into nulls and then clean them with the null handling methods. So if you see NaNs in there, just do this. df, make your own df, but I'll say result equals df with columns. pl dot call growth. I'm gonna fill NaN with none. And then I'll show you that result. Okay, so now my growth NaN is gone. It's a null. I can go back up here and do whatever I want with it as a null, and I don't have to worry about the NaN anymore. So that's it for null handling in Polar's data frames. Hope you liked this video. If you did, please like it, subscribe, and I will see you next time. Thanks, everybody.